Good morning, everyone. We are Group 5, and today we will present a comprehensive analysis for Hydrasteel Industries. Hydrasteel Industries: quality control, production uncertainty, and system resilience. This is Dan Ray, and I will proceed on discussing the core problem and framework. Our presentation is structured around a clear, logical framework to address Hydrasteel's twin challenges: quality uncertainty and operational disruption. The problem: the company faces a 3.5% defect rate, unplanned breakdowns 4 times a week, a tight P1.2 mem maintenance budget, and an uncertain plant upgrade. This creates a cycle of high costs, missed deliveries, and damaged client trust. Our framework: we will apply a sequence of quantitative models, each building on the last, to transform this reactive operation into a data-driven, predictive, and resilient system. We will cover diagnostic models to understand defect and failure patterns, predictive models to forecast machine state and project timelines, integrative models to align production with demand and cost controls. This framework provides a clear pathway from problem identification to strategic solution. To further the diagnostic models for defects and breakdowns, help me welcome Ms. Marikar.
Good day, everyone. I'm Marikar. Today, I'll be discussing diagnostic models for defects and breakdowns. The Hydrasteel company is currently facing a challenge in understanding and reducing defects and machine breakdowns. To address this, we used probabilistic models that help turn uncertainty into useful insights. First, for defect analysis, we used the binomial distribution model. In this scenario, we have 15 steel bars per batch with a 3.5% defect rate. This model helps us calculate the probability of multiple defects in one batch. The business value of this is that it predicts the likelihood of having 2 or more defects, helps us plan inspections better, and improves rework and quality control. Next, for machine breakdowns, we applied the Poisson distribution. On average, we experience 4 machine breakdowns per week. This model helps us predict how often these random breakdowns might occur. Its business value includes predicting weekly breakdown patterns, improving crew scheduling, and optimizing spare parts inventory management. Overall, these diagnostic models support data-driven decision-making. They help us reduce costs and improve reliability by turning reactive problem-solving into predictive risk management. By applying these models, Hydrasteel can better manage production quality, minimize downtime, and strengthen overall operational efficiency.
Excellent. Knowing we have 4 breakdowns weekly is good, but predicting the machine's future state is better. This is where Markov chain analysis becomes our most powerful predictive tool. I want to be transparent about our data. While the case gives us breakdown frequency, the specific transition probabilities we'll show are illustrative examples. In practice, Hydrasteel would derive these exact numbers from historical maintenance logs. We model the machine through 3 states: O for operational, M for minor fault, and B for major breakdown. Looking at our diagram, you can see exactly how the machine transitions daily. For example, if the machine is operational today, tomorrow it has an 80% chance of staying operational, a 15% risk of developing a minor fault, and a 5% danger of jumping straight to major breakdown. Most critically, when in a minor fault state, there's a 10% risk it escalates to major breakdown, but also a 60% opportunity we can recover it to operational with timely maintenance. By analyzing these transition probabilities, we calculated the long-run steady state. The machine is only fully operational 76% of the time, while we spend 18% in minor faults and 6% in major breakdowns. This means in a 30-day month, we lose nearly 8 days to faults and breakdowns. For financial context, while the case doesn't specify exact costs, we've used industry standard assumptions to estimate approximately 930,000 pesos in monthly losses, despite our 1.2 million pesos maintenance budget. The strategic imperative is clear. We must target that 18% minor fault window, about 5 to 6 days monthly, for preventive maintenance. By reallocating our existing budget to predictive interventions during these critical days, using Hydrasteel's actual historical data, we can leverage the 60% recovery probability, stop the 10% escalation risk, transform maintenance from reactive cost to strategic advantage. This isn't about spending more, it's about spending smarter using predictive insights. To discuss about strategic planning for operations and upgrades, help me welcome Ms. Vanessa.
Good day, everyone. With the predictive insight at hand, We now need tools for strategic planning under constraints. For the limited 1.2 million pesos maintenance budget decision analysis provides a framework. We can now construct a decision tree that evaluates different maintenance policies such as reactive maintenance mode, preventive maintenance, and predictive maintenance as suggested by Markov model. Reactive maintenance involves repairing or replacing equipment only after a failure or breakdown has occurred. This is to restore functionality post-failure rather than preventing it. Preventive maintenance entails conducting regular, scheduled maintenance activities based on predetermined time intervals or usage levels, regardless of the actual condition of the equipment. Its primary goal is to minimize the likelihood of unexpected failures. Predictive maintenance. This utilizes probabilistic models, such as Markov models, to forecast potential failures based on equipment condition and performance data. Maintenance interventions are performed only when statistical indicators suggest a high probability of malfunction. Through decision analysis, we can compare these three strategies by assigning probabilities and expected cost to each outcome, such as machine operating time, repair costs, and potential lost output. Management can identify which options delivers the maximum operational time at the lowest expected cost. For the plant upgrade, the project duration is uncertain with the shortest time of 3 weeks, the most likely time 5 weeks, and the longest time 8 weeks. The Program Evaluation and Review Technique Model, or PERT, helps estimate the expected duration of the project by combining these 3 times. PERT also identifies the critical path, which is the chain of tasks that must be done on time to finish the project as scheduled. This helps the management to check the chance of on-time upgrade completion, see which task cannot be delayed without affecting the upgrade, and decide on how to utilize resources to mitigate delays. Together, these tools provide a robust strategy for managing both routine operations and major capital projects. To discuss about integrated forecasting for proactive control, conclusion, and strategic implications, help me welcome Ms. Mary Lan.
Good morning, Doc and classmates. I'm Marilyn, and I'll be discussing integrated forecasting for proactive control, along with our conclusion and strategic implications. Building on our diagnostic and predictive models, we now take the essential step of integrating everything through forecasting. This integration is the capstone. It transforms all our siloed insights into a single, cohesive, and actionable production and financial plan. Forecasting is key for 2 critical strategic functions. First, demand forecasting. We leverage time series models, like exponential smoothing, on historical data, including production figures, recorded defect rates, and documented equipment issues. By analyzing past client orders, Hydrasteel can precisely predict future demand. This allows us to align production exactly with our delivery contracts, which significantly enhances customer satisfaction. It moves us away from guesswork and ensures we never overproduce and waste materials, nor underproduce and miss a critical deadline. Second, cost control forecasting. This is where the financial impact of our entire model becomes clear. We create a unified forecast that directly links the predicted rates of defects from our binomial model and breakdowns from our Poisson model to their financial consequences. This results in a powerful managerial dashboard that clearly visualizes key performance indicators, KPIs, like defect rates, breakdown frequency, maintenance budget, and the gap between forecasted demand and actual output. This visibility is a game changer. It allows managers to accurately forecast cost reductions and production efficiency gains before they even happen, turning potential losses into predictable savings. In essence, forecasting synthesizes all our data into a truly proactive strategy, moving us beyond simply reacting to problems, like machine failure or a sudden surge in defects, to actively shaping our future performance and ensuring financial stability. To conclude, let's bring all the pieces together and look at the strategic roadmap we've designed for Hydrasteel. We haven't just proposed a set of disconnected tools. We've presented a logical interlinked model framework. This roadmap moves sequentially from diagnostics to prediction to planning and finally to full integration. It is the structure that moves Hydrasteel from a reactive company constantly fighting fires to a truly proactive and resilient one. Let's quickly summarize the power of each model in this unified system. The integrated model framework. Binomial model. predicts defects per batch to monitor product quality and evaluate the effectiveness of quality control measures. Poisson model estimates breakdown frequency to anticipate maintenance needs and minimize production disruptions. Markov chain tracks machine performance across different states, operational, minor fault, major breakdown, to predict reliability over time. These models, binomial, Poisson, and Markov, form the predictive foundation, telling us what will happen and why. Now, let's look at how we use that insight to execute our strategy. Planning and strategic alignment. We then leverage two powerful planning tools. PERT CPM plans plant upgrades and complex maintenance tasks efficiently by identifying the critical path and estimating total project duration under uncertainty. This ensures that when an upgrade is necessary, we minimize downtime and maximize resource usage. Exponential smoothing and demand integration. This is the final, most crucial step, the link between production and the customer. Our exponential smoothing demand forecast allows Hydrasteel to anticipate periods of lower client demand. This insight is the game changer because it allows management to proactively schedule maintenance and staff training during those slow periods, thereby maximizing asset utilization when demand is high. The strategic implications of this new framework for management are clear and powerful. Data-driven decision-making. Our new policy is simple: data-driven decision-making. By integrating advanced models like binomial, Poisson, Markov, and decision analysis, managers can now base critical production and maintenance decisions on statistical evidence rather than intuition. The benefit is immediate: improved accuracy in quality control and production forecasting. This reduces internal arguments and focuses the team on verifiable facts. Resource allocation. We combine decision analysis with precise cost forecasting to guide resource allocation. Management can now allocate the 1.2 MEM maintenance budget more effectively, expertly balancing preventive actions against immediate production demands. This ensures controlled maintenance spending and significantly reduces cost variability, making the 1.2 MEM a strategic investment, not just an operational expense. Risk management. Our approach to risk management is proactive and layered. We use PERT to accurately estimate project timelines and identify potential delays. At the same time, the Poisson model helps us predict the likelihood of equipment failures. Together, these tools allow Hydrasteel to anticipate risks, allocate resources efficiently, and minimize costly disruptions across the entire value chain. Strategic alignment. Finally, strategic alignment ensures our production perfectly matches market demand. By leveraging accurate forecasts, we eliminate the costly mismatch between what we produce and what the market is asking for. We use integrated forecasting to enhance operational resilience and, most importantly, strengthen client trust. By fully adopting this quantitative framework, Hydrasteel Industries can transform its current challenges into a significant competitive advantage, guaranteeing long-term profitability and stability in a rapidly changing market. Thank you.